Hello, academic stars around the world. Welcome back to Caltex Academy. In case you're new, my name is Julius and thank you for coming around to this great channel. So today we are continuing with our series of the coursework from Nkumba University, Uganda, and on quantitative method coursework for business administration learners. So this one is a question for distance learning program. Let us move on and take a look at this question, number 3, part B. Part A of this question is worked in a separate video. The link is in the description of our video here. You can also go ahead and check it out and see how it looked like. So with all this, let us move on and analyze our question before answering. So question 3 part B says it is given that A is having this matrix with element of 2 and negative 1, and B is given with 3 and 1. C is a square matrix with 2 by 2, 1 negative 2, 4 negative 1. Part B, problem number 1 of the question says, determine the matrix AB. What is the meaning of this matrix AB? We need to multiply A and B together to obtain one single matrix. One first thing you need to consider while doing matrix multiplication is always to check on their order. Now when you look at this matrix, the order of matrix A is 1 by 2. What does it mean? We have 1 row and 2 columns. So a row is horizontal, columns are vertical. So we have 2 columns, 1 and 2, 1 row. Then also you have to look at this one. So we have 2 rows and 1 column. The rows are here, 1, 2, then 1 column. So when you look around at these two numbers that are next to each other, if you bring them closer together, you realize that they're the same numbers, 2 and 2. So this one tells us that this matrix multiplication is possible and say it is computable for multiplication. Now the resultant matrix will be having an order of 1 by 1. When you talk about by, we're talking about this x here, which is the multiplication sign. So that is the position, meaning we just only get one element as a result for this multiplication of matrix A and B. And you also need to take note that matrix B A is not the same as matrix A B. So while multiplying matrix B A, the order will change. From our analysis here, the first one is going to have 1 by 1 matrix. Meanwhile, for this, it is going to have a different arrangement of B and A, which is the same as B coming before 3 and 1. So when you look at their order, you realize that this one is 2 by 1, and remember this one was 1 by 2. Still they are computable for multiplication, but then the resultant matrix is 2 by 2. It is a square matrix that looks like matrix C. So that is one thing you have to note while multiplying or working with matrices. So let me erase what I've just given here before we look at problem number 1 of our question B. Alright, let's have our solution here. And problem number 1 of part B should be A, B equivalent of matrix A with elements of 2 and negative 1 multiplies the second matrix B with elements of 3 and 1. So when we do this multiplication, our AB, putting in mind, is 1 by 1 matrix. So we multiply the first row and the first column and we sum up the results together. So 2 times 3, we get 6. Negative 1 times 1, we get negative 1. And of course, plus minus will balance back to minus. So our matrix is 5 as a single number, and please don't leave this bracket out because it will not make a meaning if you leave out this bracket, since matrices must be having brackets. So this one tells us that is a matrix of an order of 1 by 1 with this one element. So 1 by 1 is the position of an element in a matrix. Like what we have here is 2 by 2. 2 columns and 2 rows. So that is the meaning of these two numbers here. Now the next one we need to look at part 2 of this matrix multiplication, which I can bring near here. And in part 2 we have BA minus 2C squared. So this is equivalent to working out this matrix multiplication, as we've already analyzed that the order will be different, and that is to the two matrices. Let's make substitution of B by its matrix 3, 1, and substitute A by 2, negative 1 matrix. So according to what we had here, we have minus 2, and this 2 is a scalar that will multiply the result of squaring C, and C is with elements 1, negative 2, 4, and negative 1. So since it is squared, then we can repeat it 1, negative 2, 4, and negative 1. So let's multiply this part separately and this one before we subtract in the middle here, following the rules of Bottomers. So here, the first row multiplies the first column, will give for us the first element here. That is 3 times 2 and the 6. So the first row and second element will give for us the element at this position, and that is negative 3. So the second row and the first column will give for us 2, a position here, and lastly the second row and second column will give us negative 1 at this position. So we're done multiplying here. Let's move on to the next one, maintaining our 2 this scalar and multiply this out. Get the element at this position, we need to multiply 1 times 1, and that is 1. Negative 2 times 4, we get negative 8. So at this position, we need to multiply the first row and the second column. Therefore, 1 times negative 2, we get negative 2. And negative 2 times negative 1, we get positive 2. So let's move on to the second row and first column. 4 times 1 is 4. And negative 1 times 4 is negative 4. And let's move to the second row and second column. 4 times negative 2 is negative 8. And negative 1 times negative 1, you get positive 1. We also close it over. Let's first simplify these elements inside here, and we also recopy the elements in our first matrix combination of BA. So from here, we still maintain our 2, and the first element simplifies to negative 7. The second number here goes to 0, and this element also is 0. The same thing goes to negative 7. Now from here, we need to open up this, the multiplying, and this gives us, remember, we're still working on BA minus 2C squared. So here, let's maintain our first result around here as we multiply the second matrix by the 2 here. Let's maintain the sign and only multiply with the number. The sign will come in the result of subtracting. So let's create this bracket and multiply 2 by negative 7, we get negative 14. Then 2 times 0 at this position is 0. 2 times also 0 here, we get 0. And this one is equally negative 14. So closing up this bracket will lead us into these two different matrices that are being combined together. And while subtracting or adding matrices, we normally deal with the corresponding elements. So this element is corresponding to negative 14, and negative 3 corresponds to 0, 2 corresponds to 0, negative 1 corresponds to negative 14. So let's subtract them in that order. So 6 minus negative 14 is like negative times negative is positive, so we just add 6 and 14 together and we obtain 20. So for this position, we have Negative 3 minus 0 remains the same as negative 3. Then we move on to the next element. Here at this position, we have 2 minus 0 is 2. And finally, negative 1 minus negative 14, we get positive 13 because negative times negative is positive. So we have something like negative 1 plus 14. And this one will reduce itself by 1 to 13, but positive. So here we have positive 13 and we close it over so that it gives us the result of this simplification. If we have matrix B multiplied by A and we subtract away twice matrix C square, and that is the answer for this part of this question B, Roman number 2. If you have watched up this time and have gotten some value from this video, go ahead and share with friends, give it a thumbs up, subscribe to the channel and click on that notification bell so that you get notified in case that you have any video on this great channel, Caltex Academy. See you in part C of this question, where I will also discuss in our next upcoming video. See you there and peace out.